Right. So for now we are going to do this question 4 from tutorial 1. So I've just sketched it in 3-dimensional so that you can be able to visualize what is happening on this question. So this is our heavy box which I drew here. So this is the box, the heavy box in 3-dimensional. So initially we have two ropes. The one that is pulling due south with a magnitude of force equal to 350 newtons. Then we have another rope that is pulling due west with a magnitude of 475 newtons. Okay, so this is what is happening now. We have two ropes initially. The first one is pulling along the southerly direction, the other one along the westerly direction. If we continue with this line, you can see we are going north. If we continue with this line, you can see we are going east. Okay, so that is our compass there. All right, so we want to replace these two forces with one force that is equivalent to the sum of the forces. So instead of using two ropes, two ropes acting at this corner, okay, now we want to use one rope to pull this box. We want to use one rope. So we want to know how much force is going to be in that rope which we are going to use, and at which angle are we going to position that rope relative to due west, or if it can be asked in another way, relative to due south. So you must take note, you have been told to ask the direction of the rope relative to which angle? Relative to due west, or is it relative to due south? Okay, so basically that's how we'll be approaching this problem. So the first diagram, it shows the diagram while we are still having the two ropes. And now in the next diagram, I'm going to replace the two ropes, one and two ropes, with only one rope. Okay, so this is our new system now. Instead of using the rope, this one, I have removed this rope. Instead of using that rope, we have removed it. Now we only have one rope, which is just coming at this angle. This is the angle which is due from the west, which is the westerly rope. So due west, so we are going to calculate the angle, the direction of this rope, due westerly direction, or due west. So we are going to find this angle. But if you were asked to find the direction due south, then you are going to use this angle, the direction of the rope due south. So just take note of this. Whether you are asked due, is it relative due west, or it's relative due south? Okay, so that's why I had to indicate that this is the angle that you would use if you were asked that it's relative due south. But in this problem, we are going to solve it relative due west, because that is the angle which was requested us to calculate. So there are two angles which we can use: relative to due west, which will be this angle, or it will be relative to due south, which will be this angle. So you just pay attention to the instructions which you are given. Okay, so basically that was the question, which is just here. The two ropes attached to the heavy box attached on the heavy box to pull it along the floor. So the idea of the two ropes in the first diagram was to pull the box along the floor. So if we replace the two ropes with one single rope, we want to find how much force should be applied by that single rope. That is what we are going to calculate. And the direction, is it relative due south, or is it relative due west? In this question, it was relative due west. So we want to determine the position, we can position the rope. So that is what we want to determine. The angle in which we can position the rope to accomplish, or the angle or direction which we can position the rope to accomplish the same effect as the two forces added together. So the two forces added together, another word there it will be the resultant. Another word which you can use is the resultant. So we are going to use the same effect. What effect? Which means is the sum of the forces. So this force which we are going to replace the rope, it must have the same effect as the two forces added together. Okay? So in other words, it must be the resultant of the two forces that we have been given. So in other words, we are going to calculate this force, which is the resultant of the two forces that we were given. Okay. So to look at this problem very much easily, we can push it back, reduce it to 2D. Can put it in a 2D sketch so that it does not confuse us much and we are able to see very clearly. So what you must know, between west and south, there's a 90-degree angle here. It's 90 degrees. And this is the angle which is due, relative due west. So we are going to use theta as the angle which we are looking for. But if the angle relative due south, you can use a different angle, which will be this one. Okay. So we are going to use Pythagoras theorem in order for us to find this force. If you are to complete this, you are going to see that this shape is a rectangle. If we complete the resultant of the two forces added together, which means this force plus that force, it gives me this resultant. Okay, so this force of 475 plus that force of 315, it will give me a resultant of this force. So we want to calculate how much is this force. So since it's a right angled triangle, we use the theorem of Pythagoras, which says that the force squared which we are looking for is equal to this one, which is the what? Opposite squared plus the adjacent squared. We make f subject of the formula by squaring the sum of the two forces. So it has the effect of the sum of the two forces added together, which will be the resultant. So once we calculate, we solve everything, we are going to get 573,2229 newtons. You can round it off to any digits which you want, or you can put it in the standard international form, which is 5,7 times 10 to the power 2 newtons. Okay. So now we want to find, now we found the force, which is 5,733 times 10 to the power 2 newtons. This is the force in the single rope to replace the two ropes which is given above. So instead of using the rope which is going in the west direction and the one going in the southerly direction, we just replaced it with the one rope. One rope of magnitude, this is the magnitude of the rope, of the force in the rope. So instead of using two ropes, now we are only using one rope. But the challenge is we don't know how or where this rope is actually positioned, at which angle, theta. So now we are going to calculate the angle theta using the law of Pythagoras, or using the trig ratios of tan theta, which is opposite over adjacent. So now we need the angle or direction to position the rope relative due west, relative to due west. Okay, so the angle is theta. We have seen it from the diagram. Then we know tan theta is equal to 315, which is the opposite side to the angle of theta, multiplied by, divided by, 475, which means over adjacent. So for us to get theta, which will be the inverse of the tan or arctan of 315 over 475. So using the calculator, you will simply find out that the theta is 33.55. And this is the angle which is due west. But if you were requested to find the angle which is due, relative due south, for now it's easy. You just have to say 90 degrees minus this. Then that one will be the answer for due south. But in this case, we were only required to find the angle relative to due west. Okay, you can continue sending the problems which I have in challenges with. I am still available to assist you with the tutorials for the problems which I have. Thank you.